So hi everyone, we'll try to start off on time and not wait for more people. We have over 300 plus at registrations for this webinar, and what we are going to do is we're going to set a precedence for all this webinar series so that we always start on time. So thank you for all of you who've joined on time, and this talk is about AI chatbot evolution. How it came about was we have been looking at the recent advances in LLMs. There's a lot of interest around retrieval augmented generation. Obvious things are like answering Q&A based on your technical documentation or building chatbots, which help customers find answers quickly. Also, a lot of our companies at Accel have started using these LLM chatbots for solving customer support issues. With that said, we found two interesting perspectives. So Jacob, who's the VP Data Science at CleverTap, they have built an internal, they have built a chatbot, and they are going to launch it pretty soon on top of their technical documentation. And him and I were talking and how he built it, and we thought it would be a good thing for this particular webinar. Also, we have Nikhil, who's the co-founder and CTO of Limechat. He had a very different perspective. He was like, using LangChain and existing vector databases, you can build some sort of a Q&A chatbot, but you can't necessarily build a more sophisticated chatbot driving users to a particular end goal. For example, having a transaction on e-commerce websites. And he's going to talk about how they are solving this problem with their tech today. And that gives us glimpses of how others can try to solve a similar problem or use or partner with Limechat. With that, let me just do a 1 minute intro about Accel and what we are doing with respect to AI. So obviously, generative AI has been in the limelight for the past half a year or so, maybe for those who have been following it for longer, for a year or so, since GPT-3. Accel has been investing in the AI space for quite some time. These are some of our companies. Obviously, Scale, almost everybody knows. They became very popular as a labeling dataset labeling service for a long time ago, and then they've become almost like an AI platform for managing models and the like. Also, just 2 days ago, we announced our investment in Synthesia, which is a synthetic video generation platform, allows people to create their own avatars. So Accel is a multi-stage firm, and we invest across stages, anywhere from 200K all the way to 200 million. So we do pre-seed investments, two people and an idea, all the way to late-stage investments. And with respect to that, we have also announced recently an AI cohort in our flagship program, atoms.accel.com, which is now going to take applications in the AI cohort pretty soon. So we are looking for anybody who's building on the AI stack, B2B applications, B2C applications, MLOps, foundational models, infrastructure solutions as well. So anybody who's building AI, as well as anybody who's using AI, we are pretty soon going to announce applications for that. Hope some of you on the call will apply for that. Also, just to give everybody a context we have roughly 50% of registrations are from founders of the 350 odd people who've registered for the webinar. Plus, we have a large number of data scientists, large number of product managers, as well as ML engineers. Plus, I'm very happy to say a lot of students, engineering students as well. So that's the split of the audience. Yeah, and that's about it. With this, would open it up for Jacob, to talk about building RAG bot using LangChain and vector databases. Jacob, all yours. I'll stop sharing. And it'd be great if you could share your screen and come online.
Thanks, Frank. So I think before we start, right, I'll just give you a context on.
So Jacob, we can't see your video. Do you want to switch on your video, or?
Yeah, just. It's saying unable to start video.
Oh. Okay. So I'll figure this out. You can please go on with the session.
Yeah. So let me, first of all, let me introduce what CleverTap is all about. CleverTap is a leading customer retention platform. So basically, if you have ever used Paytm, MPL, Geo, and there are a lot of other apps, around more than 8,000 apps worldwide who use us. So if you use any of these products, you've used CleverTap in a way. They use our platform to power their analytics and engagement. So all those timely notifications you get, it's courtesy our platform. So now, see now, this is true for any platform or product wherein there is a documentation resource. Now, how could you? I mean, how do you? How often do you go to that documentation page, right? It's only when you are facing a lot of difficulties in understanding the product or some nuances you go to the documentation, and that too sometimes what you kind of try to find it's like finding a needle in a haystack. So that's a kind of a challenge, right? How to make your documentation readily accessible, and also creating that user experience, the customer experience nice. So we were looking, so with this generative AI and stuff, we were evaluating certain chatbots, and the plan was not to build it on our own. We were looking at some tools, and we found that we were not getting the requisite responses. So some were giving outright wrong responses, some were hallucinating, some were not returning the code. Many, actually, most of them were not returning the code because you're dealing with developers, right, who want to integrate stuff, and so the code was an issue. Then again, if you're looking at any features, images also play a nice role, right? Images of the dashboard, the specific feature and stuff. So these were certain challenges that we were facing. So what we did at our data science team, and we just thought, why not build it ourselves? So we took a shot of that, and I think within a few hours, we were able to create the first version of the chatbot, which was giving us pretty decent answers, better answers than what the other tools were able to do. So that gave us confidence, and we thought, let's build on top of it. So now we are at a stage wherein the bot is able to return us the relevant code, the images, and also we've gone beyond a stage wherein we are looking at multiple sources, not just the documentation, but also our blog. So, for example, if a marketer has a problem as a general marketing problem statement, for example, marketer may say, okay, what is the life cycle marketing all about? So that answer is not necessarily in the documentation page; it is in the blogs and other material. So we'll source the relevant snippets from the blog, and then if the marketer said, okay, how do I implement it in CleverTap? So that is where we will utilize the documentation side of things. So this is the stage where we are, and we'll be shortly, putting it in production. So without much ado, so this presentation, there's a code walkthrough that I'm going to go through is basically creating a support bot for LangChain itself. So let me share my screen.
Jacob, can you try switching on video now? I've made you co-host.
Yeah. Yeah.
Sorry for this, folks. Nikhil, can you also try just once opening your video so that we know it's working for you as well? All right, cool. Thanks.
Awesome. Okay, so let me share my screen. Okay, so now what is my, first of all, we need to look at, what is the source? The source of this is the LangChain documentation page. So it has all list of HTML pages, right, within it. So the first is basically first scheme of thing is basically to scrape these web pages. So I have written, and this code will be shared with you guys. So this, Frank, are you able to see the screen? Is it
yes,
too small?
I'm able to see the screen. Yes, it's all good.
The code, it's it's readable, right? The code and all.
Yes.
Cool. Okay. So here, I mean, I've used Beautiful Soup to kind of scrape the relevant URLs. So what we'll do first, we'll scrape the URLs, and from the URLs, we'll get the content. So these are some helper functions. You can go through it. I don't want to spend a lot of time over here. So here I'm putting the links, and basically I'm getting around 600 URLs. The next step is get this, get the content from the URL. So LangChain actually has a lot of document loaders. Like basically the job of a document loader is to load the specific content. It may be, and these, you may have PDFs, you may have, Excel, and there are a number of, loaders. For example, let me just look at the loaders, indexes, document loaders. So there are a number of, document loaders over here in LangChain, which makes life really easy. You have even Jupyter Notebook. So what we will do is we will look at the URL loader, the unstructured URL loader. There is also Selenium URL loader. Now these are simple web page, HTML pages. So we look at unstructured URL. So now what the input to this is a list of URLs. So we had around 600 URLs. I'm looking at the first five, and I'll be loading this. And basically, in order not to spend too much time over here, because when I did it, took me around 15 minutes to load the entire URLs, 600 odd URLs. So I saved it under a separate, object. And also, now the next part is basically looking how the data look like. So I'm taking a specific instance of a specific URL. So this is the GraphQL. So this is the data. So had some code responses and stuff. And if you see, it returns a list. Now this list has just one element because I'm looking at only this URL, the GraphQL one, and it gives me the response. So there are two things over here. One is the actual document, which is the GraphQL, which is this actual document. And it returns the metadata also, which is the source. So very useful. The source will become very useful later too. So now, you have this and stuff. And then, okay, now the documents are loaded, right? But what's the next step? Can I give this document as is and to a GPT and try to make sense of it for any task? May it be summarization, may it be retrieval or whatever, right? Or some question answer thing, right? So that itself is not a good idea because, as you know, GPT has a token limit, right? Earlier, the 3.5 had around, I think, 4,000 token limit. Now it's increased to 16K, and GPT-4 has a much higher token limit. But still, you will face an issue where some of documents are much higher than that token limit. So hence, it becomes important that you split those documents. And there are a number of splitters available in LangChain. And we will look at one such splitter. Recursive character text splitter is a very versatile splitter. what it does is it will ask you the main two arguments. There are a couple of more, but I'll stick to the main, is the chunk size, how many characters you want to have, right? So here I'm looking at a character limit of 1,000. So if a document has more than 1,000 characters, it will break that. But and there is a chunk overlap. So you want to maintain some continuity in the document. So one document, if it is broken into two parts, there will be certain characters which will repeat in the next document. Another thing to keep in mind is chunk size, even if you say 1,000, but there are some separators given in recursive character text splitter. So it starts with 2-line breaks, right? If there is a 2-line breaks, it will suppose there is a paragraph, and after that there is a 2-line break. Then it will cut that splitting till that paragraph, and then the next paragraph will be another chunk. So, and there are various other so there is 2-line breaks, and if still you are hitting that character limit, it will go to a 1-line break, then it will go to a space and character and stuff. So there are separators which are mentioned. You can give your own separator also. So so this is how it is. So now if you see, when I split this page, now it is splitting me in in this way, right? This is the first page. The page break, I've kept it as these hashes, right? So now even though it is not hitting 1,000, it will still have this page break. Now if you see, this is repeated, right? So this is the way it does the splitting. Now, one issue, if you might have observed earlier, is if you see this code, right? Pip install, these are all coming in the, with a line break, which is not correct. The one that we had saw that in the page, it is nicely structured, right? The code is nicely structured. Pip install, HTTPX, whatever, right? So from LangChain and all this. So it is nicely shown. But here, when I'm doing this with the this URL loader and scraping it, it's not coming properly. So there is another document loader, markdown loader, which is very convenient, a loader. So it converts any HTML kind of any URL into nice markdown file. So it is basically very convenient and gives you the right. Now, obviously, I'm not an expert in scraping web and stuff. So I mean, majority of you guys will be expert, much more higher expertise than I have, at least 10 times. But you can do a much better job at this. For me, this was a very convenient approach. So with this, the same thing that I've done, I've given two markdown loader, and this is how it is coming. So nicely it is structured, and this is an ideal scenario. And once you have a markdown file, there is again a markdown text splitter with that, which LangChain has. So the idea is it takes the markdown file and divides it basis the tags and stuff, right? The headers and stuff in the markdown. So nicely it splits the markdown file itself. So this is how it's done, right? So all the code is coming together, and so all that is being maintained. So this is on the markdown. This is another example I have given here. Okay. So now, once you are comfortable, okay, now we can give the entire list of URLs, and just this is a docs variable that I've created, and then I'm just adding it to it. So I have all the you have scraped through all the URLs, and then obviously the next is getting the chunks, distributing it into chunks. So from around 600 odd the URLs, I have got 6,000 basically chunks after splitting. So here again, you can be intelligent about it. Maybe you want to see, okay, how do I know what is the distribution of my chunks in terms of the tokens and stuff. I have created another function for you, a helper function. So basically what it does is there's a tick token, it helps you to calculate the tokens. So here you can put in what sort of encoding you want, right? What sort of model you're using. And then it calculates, given any document or chunk, it will tell you how many tokens are there in that. So if you see in the base doc, we had some tokens which was in over 10,000 also. So the average is around 2,000, mean is around 2,000, median around 595 tokens, and highest is literally very high number of tokens. And once I did split it by the chunks, now it's very manageable. So the average is around 183. And the highest is around 738. Now, why this becomes important is because when you want to have a support bot, there is a conversation going on. So first you want to get the right number of documents from your entire list, because the entire list can't fit into a GPT. And then from those limited number of documents, the token size should be within the limits of GPT. And then the GPT returns the output. Now that output becomes one of the input to the next chat, because you want to maintain the context. So that gets on adding, right? So you need to be very vigilant about this. So here, this seems like a very manageable thing. So now let's come on to the main stuff. Now that you have the chunks and then now you move on to the next thing is basically the OpenAI side of things. So how do you know which are the relevant documents for a specific question? So then you have to create some sort of a database wherein it gets you the right answer or few documents based on your question. So you have to create. So probably you have to create some embeddings. So here we are using the text data embedding of OpenAI, and the dimension side is 1536. So every document, every chunk, sorry, not every document, every chunk is converted into an embedding. And that embedding we need to store somewhere, either it's in your local or some managed services. And then you have to get the semantically similar documents related to the question. So how do you do that? There are open source options. You can do it on your own. There are open source options like Chroma and Fairs and all, or there are managed services like Pinecone. I prefer to go with Pinecone, is because it's first of all managed services. The managing that database becomes easy, and scale also. No need to care about the scale. They are pretty fast. And then and the most important thing was the pricing part. Up to 100,000 vector embeddings, right, is free. So that's also good. And here we saw like it's 6,000. So pretty much within limit. That's the starter plan. And also, you can update, you can delete, and all those stuff can become very, very, very easy.
So Jacob, sorry, just to take a pause here and ask you one or two more questions. One is this is something which keeps coming up in our groups, choosing the right vector database, VV8 versus Quadrant versus Pinecone versus, people are using even Elastic has, and most of the large providers have started doing it. So one of the questions I have for you is like Pinecone is not something which you would have been using beforehand, right? It is something which you were created when using with Lang. So you're adding something new to your engineering stack. Why not use like I don't know if Postgres has or Redis, you must be using Postgres or Redis. Why not use their vector data stores? Because of pricing again, or something else?
No, to be frank, this entire support stuff is so, recent, right? We're solving it's hardly like a month or so. We've put our hands and feet and got that. I mean, it happens so fast, and we hit the what you call the treasure so fast, right? So we couldn't have time to experiment a lot of things. And secondly, when you know that at the starter plan it's free, right? So why do so that was again, I have not done an in-depth study across vector databases. I know Redis has, there are a lot of other stuff, but I just tried it with Chroma and Pinecone, and surprisingly Pinecone was outperforming Chroma. So that was a surprise for me too. But yeah, I mean, but maybe for some later date we will have some sort of comparisons.
One more question. So you said Pinecone was outperforming Chroma, and that was happening. You checked with speed. You checked like how did memory consumption or
quality of response.
Oh, quality. Okay, very interesting.
For us right now, major thing is quality.
Okay, quality of
because see, we are a B2B platform. Okay,
right.
We are not serving to 100 million users or 10 million users. Right? It's a limited number of apps. But then for me, the major point is quality. And speed, because we already have a feature which is using GPT. We are quite comfortable with the speed aspect.
Okay, got it. There are two more questions from Shashank. One question is, what is the machine setup to run Jupyter?
Machine Jupyter. This is nothing. Local. Yeah. So the infrastructure is all GPT, Pinecone and stuff. There is nothing. You can have a T2 small instance to run this, no problem.
Correct. Yeah, Shashank, like I also do experiments with this on my local host and on my machine, which is like a M1 Mac with 16 GB RAM. But I'm sure that this is just a simple Python code. It does not put any because all the calls are API and going out of your system. So, and then second question, which is asked is, you in the beginning you mentioned that there was some custom tool which you had built, which was you had used, which was underperforming this 1 hour build solution. So we wanted to know, can you name the tools?
No, absolutely not. I wouldn't want to.
Great.
It's not good. I mean, ethically also to name those tools, right? Yeah.
And I think Arvind Nagraj has responded to Shashank saying that you can run Jupyter Notebook like this on your Raspberry Pi 3. So that's an all right. Yeah, I think Jacob, please take it from here.
Yeah. So these are some helper functions, right, for embeddings, the chat, OpenAI. I mean, this is basically self-explanatory, and then getting the okay. So let me just quickly go to Pinecone. So once you sign up, there is this indexes, collections, API keys and stuff. So, I mean, you need to focus on the indexes part and the API keys. So here, if you...
So Jacob, one small thing I just want to add to all the listeners and viewers. Basically, when you create your Pinecone index, you have to create the dimensions to be 1536 so that it can take OpenAI embeddings. It is something which a lot of when people start off, they don't know. So just a small thing.
Yeah. So just a second, let it load. Yeah. So basically, when you create, you will be asked to name the index or some naming convention, and it will ask you for the dimensions. And OpenAI dimension is 1536, and you name it, and that's it. And you can choose the metric cosine. Cosine works best, unlike the Euclidean. And then the next step is basically, okay, this is the embedding side for OpenAI, and here we using the Pinecone from text, and here what we had looked at the we had split the docs, right? I named the variable doc split. So I'm going over the page content. You have to give the text and metadata separately. So here I'm going over the page content. Page contents has the content, actual content, and the metadata has all the metadata. Okay, and you can, and the index name is what you saw, the docs GPT MD, and embeddings is the OpenAI. Index type, you can leave it blank, but I've given it exact rather than, because, there is, I mean, if you're looking at 10,000, 20,000 kind of, vector sizes, it's hardly anything for a normal vector database. So I've gone with exact. Cool. So this is already we've covered. Okay, now this is some helper functions for the chat. Now here, this is important if you want streaming kind of responses. Okay, now like GPT does, like that is streaming. Instead of waiting for the entire response and showing, as and when you get each word or character, you just show it. So here, this is a conversational retrieval chain from LangChain, which you can use. This is specifically for conversations. And here you need to put the chat OpenAI model, and here is for the streaming. Retriever, there is one of the important what we call the parameters is the where are you retrieving your documents from, right? From the vector databases. So there is this is an as retriever. The DB was that database, and here I'm also using the return source equal to true because also I want to know the source documents, right? So if you see over here, you can also create your own template of the prompt. So the default template is given the following conversation and a follow-up question, rephrase the follow-up question to be a standalone question in its original language. So you give the chat history, okay, that's a variable, and a follow-up input, which is a standalone. So it knows, the prompt itself knows what is the context and the standalone question and the question itself. So you can create your own prompt template also. But I found the default one working beautifully, but you may have your own prompts as well. So if I go over here, right? So maybe I want to ask. So let's look at the first case. Now this is without the source documents. So you see, this is the streaming option which is going on, right? So now if you see, how is this response variable looking like? So there is question, what are agents? Chat history was null, no, and this is the answer, right? Now answer is fine, but maybe there is more context to it, or maybe I want to go to the exact source document. So that is where this becomes very useful. So return source document is true. So now it gives you, by default, it will source 4 documents. And here, if you see the content and the metadata, the source. Okay, so tabular, then the agents. This seems, so all this is relevant. The tabular part also, there is the agents is there. Then this is the agents HTML. And again, this is a repeat because this was broken down into chunks. And if you can give a unique stuff, it will give you the unique one. So this kind of, so if you say, for example, if you want response, what is this, source documents? It's a dictionary that is returned. So first element dot metadata. That's it. Okay, so this is how you can get that. Now, this becomes interesting if you have the actual app, right? So I have created a simple Gradio app to have these conversations. So so basically, this is some helper functions. So what it does is, here the history comes in. I'm doing some modifications to history, because with every history I have to also to give the source, right? But in the context, I shouldn't give the source, right? Or need not give the source. So I'm removing the source wherever the source is, and then I'm giving the context only without the source, the chat history without the source, and the user messages as is the standalone question. And then here again, I'm doing something extra. So what happens in the source documents is you don't get that cosine similarity, right? That number. Now there may be a situation wherein, and the source document is not in any order, right? So maybe a similarity for a particular source was lower than the other source, right? The ones which are below. So maybe I want to show the source which has a higher cosine similarity on the top rather than on the bottom. So here I'm doing another search. I'm hitting the I'm hitting pine cone, and I'm getting whatever answers I've got. I'm hitting pine cone and getting that relevant. I'll get the same documents, but I'll get with the cosine similarity also. Now that becomes useful for me if I want to do some more, permutation combinations on that. So this is something you can also do, and that hardly costs anything. And here I'm adding to each answer, I'm adding the source, and that's it. So let's start. Okay, so let me ask, say, what are the use cases of LangChain, right? Now, if you go in LangChain, getting those use cases is kind of difficult. So let's see. Now here for this Gradio app, the streaming is not enabled, but you'll get the responses. Depends upon what is the size of the responses. For example, if you see over here, right? This again, it is started giving me the response. It's not appearing over here. Okay, now it should have appeared. So it's giving me, okay, LangChain can be used in a variety of ways. Some of the common use cases are personal assistants, question answering, chatbots, querying tabular data, interacting with APIs, agents, data. A pretty good response, right? And now, but if you see the source, right? I mean, where is it getting this data from? Let's look at this. It's getting from sitemap or something. I don't know what is it, but let's see. Personal assistant. So yeah, there is some personal assistant. There's question answering over docs. And likewise, if you search for others also, you'll get this thing. Now, if you do it at your end, will you get the same response? Most likely, yes. Why? Because I have kept the temperature at 0. So ideally for private docs, you wouldn't want surprises. You would want the most, expected response. So that's where this is, okay, cool. So now we have this. So maybe, I want, okay, I saw this personal assistant, right? Okay, now I'm not giving the exactly personal assistant. I said, okay, explain one in detail. So okay, cool. So yeah, so yes, LangChain can be used to create personal assistant that can take actions, remember interactions, have knowledge about your data, provides a standard interface for agents, selection of agents to choose from, and blah, blah. So it's giving from these sources. So you saw some agents being mentioned. So maybe, I want to say, okay, what are agents? Okay, now it's saying, okay, in the context of LangChain, agents involve a language model making decision about which actions to take, taking that action, seeing an observation, repeating. Now, agents, as you might have also seen, right, in that some of the demos, right, wherein you have a math problem given to an LLM. Now, LLMs are based on text, right? It's not based on maths, numbers. So how do you get the right answer? So then there is a LLM math agent, and there was something on the Wolfram, right? Integrate plugin of Wolfram. So these are, you can kind of call it as agents, right? So you first give the math problem, and then you give a text related stuff. So in our case, agents in CleverTap is like, there is an agent for documentation, there is an agent for a blog. So based on that, it will interact and see, how to best give the answer, reply the answer. Now, if you see, interesting thing over here is there is no mention of agents or anything in the source documents, which kind of, though the answer seems fine, but the source seems, it's not that accurate. Can it get better? So here, the challenge over here is you're giving some context to the chatbot, and it is in that context. Now suddenly you're changing some of the the context. Sometimes it becomes difficult for the bot to answer. And why I'm drawing you to this fact is this is a real business problem statement, and this you will have when you build your own chatbots with LangChain, GPT, and stuff. So how do you take care of that? So I'll give you a quick, if I clear the conversation, and if we give, and the chat history is removed, and now if I ask, so now it is giving me a different answer, and most probably a better answer. So if you see, right, it's got from this action agents and stuff, right? Action agents and plan and execute execution. So earlier also it was not a wrong answer, but the quality of this answer is much better. Then maybe, we talked about some documents which are to be loaded, right? So let me, which are the types of documents that can be loaded with, LangChain. Okay, so LangChain provides support for various types of documents, including Word, Open Word document, Pandas, data. So it's a listed out, few document loaders, and source also seems, quite correct. So maybe I want to know, okay, how do I load HTML, documents? Great. So load HTML documents. It's giving me again the right response, right? Maybe let me ask, what is the use of text splitters, right? We did a lot of splitting. Okay, the purpose of text splitters in LangChain is to split up long pieces into smaller, semantically meaningful chunks, often sentences, and then combine. I mean, pretty clear answers giving the text splitters, its source and stuff. And maybe, I want to list the different types of text splitters. The two different ways to customize text splitters, right? So here, this is specifically talking about a specific, text splitter, which is recursive. And it says that is, but, the question was, maybe I want to have a specific, I want to list the different types of, text splitters. Maybe I'll clear the conversation and then ask. So it's giving me all the types. So this answer was much better, right? So
Jacob, sorry,
yeah.
this is the one question. There are a couple of questions around quality, right? So
yeah.
people have, I'll just repeat some of these questions. Is quality essentially relevance of response in context of query prompt? Or how do you quantify quality? How do you evaluate responses? Like, is there some sort of process you follow, or is this right now very subjective?
So so when if the best way is when we right now when the internal search happens, we kind of expect the users to give feedback on the kind of responses they want, and especially responses where they have seen a negative feedback, wrong answers, outright wrong answers, or where the quality was not that good. So outright wrong answers, I mean, hardly we had a situation. Quality of responses, in some cases we had, but majority it was good. Because how the document itself is structured also plays a role. If you have a document which is very like, it's not nicely structured, then you will find an issue over there. But if you're talking about major companies, the documentation is nicely structured. So ideally, you shouldn't have that situation. But yes, and when you do it in production, you should always have a feedback mechanism to try this out, right? To understand how the responses are coming in. So we'll have those feedback mechanisms to understand, because I mean, I can tell you one thing, many a times we have seen, especially, with respect to the NPS stuff, if people are not good, they're not happy, they'll write long responses compared to situations where they are happy. They will just give some score and, they won't write and mention anything. So we get a lot of insight from the wrong responses rather than the right ones.
But today, so thanks for that. But today there is no like sophisticated LLM testing suite or quality assurance suite which you have, which you can say. So you can say this is the best answer for this question. Like you can create a test suite of 100 questions and an answer, and say now that my response is coming is good or bad. Right. So that we don't have right now. Have you seen any of those?
So we have the list of questions which we have done internally, right? That we have seen, but then we don't want to bias with those set of questions only, right? Then it becomes biased, right? So we have kept it open. Ask it whatever you want, right? Because that is the way it will work in production. Because whatever you do, you may not have control over the kind of questions people ask. So we have kept it open, and then we have recordings on where it has not gone right or where it has gone, it's given. So like I said, we haven't had a situation wherein, hardly has a situation wherein, there is a completely wrong answer. The quality of answers may be improved in some cases, especially where there is the context switching. And generally, context switching in our case is not going to happen to that extent, because when you are on a specific feature page, right, you are specifically asking with respect to that feature. When you have doubts, suddenly you're not switching context entirely. But that's a good problem to solve, the context switching part.
Thank you.
Well, I think I had this much on the, on what I wanted to showcase. Any further questions on that? Otherwise, we can start with Nikhil.
No, great. I think there is a bunch of questions on Q&A. Thank you, Jacob. And then folks, please feel free to post your questions on the Q&A window so that we can answer those. One of the questions which has been asked is there any advantages of using Pinecone instead of Postgres with a PG vector plugin? I'm not sure whether you've experimented with that.
No, I haven't experimented. I'm not experimented.
Okay, no worries. And then I think this is another question was, if a document is bigger than the limit, then can we break and divide into multiple documents, or will it lose context? I think this has been answered. I think we talked about splitting anyways. So document loader splits into chunks and then you can stuff them. Ankita, and also as Arvind Nagaraj, who's one of the attendees, has pointed out that OpenAI just increased the context window to 16K, right? So that helps a lot, I guess. I don't know what kind of performance degradation though it brings in retrieval search though, right?
And also the price is double than the one which is the smaller one. So the smaller one is $0.015 per 1,000 tokens. And the recent version is for the input, they will charge $0.003 and output they'll charge $0.004.
Yeah.
So obviously the price is different.
Yeah. Next question is, what is the quality difference in Pinecone? Don't all vector stores have the same L2 and cosine similarity operations? You pointed out that, Chroma versus Pinecone, you found Pinecone's answer is better. So why that kind of a difference is happening?
Yeah, so like I said, this has happened so fast, right? So I've not got time to delve into, more details, why this is happening, because these are all algorithms which are available, right? I mean, anyone can do that, but maybe Pinecone is having certain things proprietary, which is it's not divulging. And that's one aspect. Also, the ease of managing and stuff. So, and for us, it was a no-brainer, right? It's free for at least for the 100,000 vector embeddings.
Yep. Then there is another question. You mentioned that for CleverTap, you divided your documents into tech docs and blog. Question one is, did you put them in different collections, 2 different collections, or you put them all together in one collection?
No, all together in one index with separate namespace.
Okay. And second question is, did you have 2 agents for retrieving or querying on each? So same agent can query both, right? So
the same, you'll have 2 different tools.
Yeah, 2 different tools.
And then, yeah.
And then did you also experiment merging both of them in the same names? I think you already given the answers. Yeah. So basically the question is, did you merge the documents or all of them? Like, I think the answer, it has been answered. So
yeah, so by namespace, if you do, it's all taken care of. So you can, when you create your retriever, this DB, right? Where is it? One sec. Yeah, so this DB retriever, there is a namespace which you can define. So here you'll say is the namespace is so and so.
Okay, great. Okay, a bunch of questions. If there's a paragraph that gets splitted, and maybe Jacob, maybe what we'll do is, in the interest of time, you can look at some of the questions and type the answers out to them. Everybody will be able to see those answers. And then we can bring on Nikhil. Right. So Nikhil, it'll be great to have you. And so Nikhil is the co-founder and CTO of Limechat. And Nikhil, why don't you go tell us about what Limechat does, and then take it from there, please.
No, absolutely. Thanks so much, Priyank, for organizing this. Jacob, thanks so much for that very insightful session. I actually personally learned a lot, and I got to try out the code, luckily, before the session actually started. So I had a blast doing it. I'll give you a little bit of background about myself. So I actually graduated from IIT Delhi with a bachelor's plus master's in large language model design in generative AI. And using that knowledge, we actually started Limechat in March of 2020, where we are actually leveraging the power of conversational AI to help automate all type of customer interactions and engagement with between an e-commerce brand and their customers. This comes from a support automation side, from a sales automation side, and also a marketing automation side. So we've been working in Gen AI or large language models long before it was cool. And it's very exciting to be part of this new generation of, I would say, models that have come out and have just changed the game. So, trying to understand, knowing the inner workings of how these models work and understanding the business implications of how to actually apply them has been a big area of focus for us. And I think that is something that I will try to present as much as possible in depth as we can go in the interest of time. If there are certain type of things that people want me to cover, you can just let me know or just pause me in between. Anyway works. Priyank, whatever works.
Sure, I'll let you know. Yeah.
Amazing. So I think the objective here is Jacob actually took you through a live example of how to leverage some of the latest frameworks such as LangChain. And it does a great job at kind of making it easy for you to build an entire end-to-end pipeline to reach an end goal. And the task was very clear. You want to make a retrieval system. However, not every single system kind of falls in the same category. And we'll kind of cover how complex systems differ from something like information retrieval and what type of trade-offs you actually have to take. So for this, I actually made a small presentation. Let me share my screen and I will take you through it.
We can see it. Yeah.
Perfect. Let me just move into slideshow mode. Yeah. So the whole purpose here is, again, how do we leverage the latest technologies, in this case, GPT, for goal-oriented task automation? That is the big thing. And I think one thing we have to really understand is what are goal-oriented tasks? I mean, you might have heard of this, but what is it really? And to understand how to build a good automation system, we have to dive deep into what this is. Well, these are pretty much purpose-driven tasks designed to help a user to kind of reach a well-defined end state. An example of this, which I put over here, is like scheduling a doctor's appointment, right? You would say that you've reached the goal state when the ultimate goal of booking an appointment is done. It's well-defined. It's a yes or no. It's very clean. There's no gray area over here, whether or not the appointment is booked or not. And that is what a goal-oriented task is. Now, there are complex and simple goal-oriented tasks. There's, like, I would say the single step tasks are pretty easy to handle. For example, question answering, which is something that we just saw right now. These are typically one turn or one step tasks. And in question answering, you have to just provide a direct answer to a query. You also have things like text improvement, where you give in some input text. This is something that everyone is very familiar with when you use GPT directly. And there's a whole bunch of other very simple, straightforward tasks that you can actually build that have a defined goal. On the other hand, there are a lot of complex systems as well, which require a lot of intermediary steps. And maybe in some cases, you actually have to retrieve some information in between at the same time, such as order cancellation, product recommendations. This requires you to actually discuss or talk with the customer and kind of fetch the information. For example, in product recommendation, if you wanted to help someone find the right type of product for managing their low blood pressure, you would have to ask them a couple of things, like how low is the blood pressure, how long it's been, and then you can kind of help guide them to a certain section. And then there are a lot of limitations as well. You don't want to prescribe medicine to people with these type of goal-oriented tasks. So where do you draw the line? Till what point can you actually give an assisted kind of automation? And then when do you hand off to an agent? So we'll kind of deep dive on how to handle both single step and multi-step tasks. I'll kind of go over that. So again, this is a little theoretical, but it's very important for you to understand how automation will really work. Right. Any goal-oriented task requires you to kind of think of it as a logical framework. And this logical framework should have something called a happy path that you can follow. You can go from the start to an end state. And at the same time, it should have the ability to handle any type of exceptions, or also offering an alternate paths to reach the goal. And what we kind of call this in theory is called a DFA, or deterministic finite state automata. And these automators have a start state and a goal state. And they can be very simple also. They can be very highly complex as well. I've given two different types of examples for you to kind of ponder over. The first one is pretty straightforward. You have a start state, and this is the same thing we talked about, creating an appointment. Now you collect data, and you kind of have to do some kind of intermediary checks. If there is availability of that slot, you can go forward and create an appointment. If not, you go back and try to get the data again. So there is certain logic that has been put in. And in the end, to solve that goal, you want all the steps of the logic to be followed, right? So it's basically a rule engine that needs to be done. You can have a much more complex system as well. Like this is, for example, product recommendations over here. This could be quite complex. I'll just take you through this quickly. For example, you can collect a concern from the user. If you're confident that you've understood what the concern is and what the user wants, you move on to the next step. Otherwise, you keep going and asking again and again until you're sure about what you want. And you kind of extract the intent and the concerns over here. Now, you could have very specific logic in between as well, where based on the concern you get, I want to just share products. In some other kind of concerns, I want to actually give the diagnosis, and maybe share just one product, whatever logic you might want. And there is some kind of, if else kind of conditions kind of handled over here. And then again, based on certain points, you might want to share the payment link or take them to the website, etc. So there's a lot of loops, a lot of nooks and crannies, but in the end, as you understand, everything is a well-defined logic. So no matter if you use a rule-based engine or you use ChatGPT or you use anything in between, all automation systems will start with some sort of infrastructure like this. Now, conversational AI's role is to help and interact with the customer and guide these customers throughout this DFA or this kind of logical system seamlessly. And over the years, we actually have various type and various levels of conversational AI that have evolved that help us kind of reach this goal state. I'll kind of cover each one so you kind of see how things are evolving over a period of time. The first one is called level 1, conversational AI. This is approximately 15 years old now. The first kind of systems have been around for quite some time. And literally, it is a hard coding of that DFA. That means users can only follow that predefined option. They have only a couple of buttons to click if there is a decision that needs to be made. And there's no flexibility at all. And it will make sure that you reach the goal state. It's not a very optimized path. It might be a long path, but it will make sure that you're either in the middle of the flow or you reach the end state. Now, as we know, this is very constricting to people. So after 5-6 years, a whole generation, I would say maybe every 7 years, we would have a new generation. So generation 2 systems kind of came in, which allowed free text for the first time. So in the middle of this flow, you can actually ask free text queries. And this is basically called a mild deviation from the actual path. And the system will try to take that free text, try to give you an answer, and kind of come back to that predefined DFA. That's the whole purpose. I've highlighted this in a diagram to make it easier to understand. So you start from the start state, and you just want to reach a goal. And it's a very simple state. You just collect some user input, and you go to the goal state. However, at the time of collecting user input, someone gives a very random free text query or free text question. You are actually deviating from the path. You will try to attempt to answer that question. You try to share the answer, and then what you do, you go back. You go back to the previous step. You don't just hang around there. And if you're not able to answer, you go to a failure state. So these type of systems were basically what we would say, they allow you to do minor deviations from the actual path, but you had some flexibility in asking a free text query in between. Now, the next generation, again, after another 7 years, we kind of came up with something called level 3 conversational AI, which allowed for much more advanced navigation. And I think the biggest change between level 2 and level 3 is the fact that level 3 systems have something called memory. That means they can remember which states they came from. They can also remember, they also know what the goal states want and whether or not you have enough information of where you are to actually reach that goal state. And this allows you to actually skip steps as well, or go back or jump flows. It's a very dynamic thing. So imagine you having this really large DFA defined. Level 3 systems allow you to kind of build wormholes from any one part of this DFA to another part of this DFA. And you can kind of move back and forth, and it remembers every single point it touched in the past. Kind of the way that you talk to GPT right now is, I would say it has memory, it stores memory, so you can kind of feel that. Every single time you ask a question, it doesn't forget about what you did before. So it allows you to jump in the middle of the flow. And these are the type of systems we're working with with these days. So right now we're in the generation of level 3 conversational AI, and we have a lot more freedom to actually navigate these paths. And this is what the expectation from the industry is going to be. So if you're building anything around conversational AI, you're building anything around chat automation, the industry expectation is now level 3 systems. So you have to figure out a way to leverage memory and move away from level 2 systems, which is what predominantly exists in the market even today. So the next part, now that you kind of understand how we think about automation, how do we build a logical framework around automation, I'll kind of go through what the latest techniques are to leverage AI to help you build these automation flows. If you want, I can stop for any questions. Otherwise, I'll move forward with explaining some of the AI capabilities of how to leverage GPT.
Yeah, I think right now there are no questions, Nikhil in particular, but except will you be sharing this PPT with everyone is the one question.
Yeah, for sure.
And so then one question from my end, since there's none from the, like, so the, this today when somebody needs to build their own level 3 kind of conversation, is it like very sophisticated, or you think if enough people are existing technologies enough using LangChain and OpenAI, you can end up building level 3? Is that possible today, or they need to have beyond that stack something else as well?
Perfect. That is exactly the segue to my next part of my presentation. So I got you covered. So exactly, building on exactly what you said, let's look at what we actually have available right now. And what are the type of challenges? So I'll talk about both the capabilities and the challenges we face with current systems and where it becomes quite challenging. So the first thing is leveraging GPT by itself, like as a in its natural state, I would say. So in the left hand side, you kind of in this bubble, you can kind of see the goal to run first of all, what the goal is to use GPT to create structured outputs that can be used as inputs to the next set of GPT functions or systems. If I have a bunch of states that I need to traverse, then GPT should be able to bring me from one state to the next state, and then that state to the next state. So it needs a way to communicate between these states, first of all. It also needs to be very well equipped to understand that there are guardrails. It must move from one state to the next state, because it's very hard to put guardrails in GPT by default. The only way to do it is by creating prompts, right? And that leads us to a big risk. The failure rate of these prompts is really high these days. Even with GPT-4, I would say the ability for your output to be exactly how you define it in the prompt is only maybe 80 to 90% of the time. So 10 to 20% of the time, you're actually failing. And it's not giving you an output in the way that you wanted it to give an output. And what happens, and this is where the complexities start happening, when you want a large, like a DFA or a large kind of automation rule to kind of play out, every step which is being handled by GPT, this error rate or this failure rate kind of accumulates. And anything that's more than 3 to 4 turns, it becomes almost impossible to use something like GPT natively to actually get it done. Now, we talked about LangChain, and we'll go deeper into that as well. But LangChain was the first implementation to actually break down this entire like GPT leading to more GPTs. Instead, what LangChain does, it provides checkpoints in the middle of this chain. And so GPT just has to make sure it reaches the checkpoint. Then LangChain ensures the checkpoint is well managed. If there's any pre-processing, post-processing that needs to be done before it sends it to the next part. Right. So some of these errors are mitigated, but you have to understand what it does, it just helps you mitigate the compounding of that error, but it doesn't help mitigate the failure rate, the 10 to 20% risk that you actually have. Right. And this is where something exciting has just been launched. And in fact, this is an announcement that just came out on June 13th. It's less than 48 hours old. We're all trying to figure out how to leverage this. But there's something that was launched called GPT functions. And what they do is they help you reduce that risk factor, the 10 to 20% risk or hallucinations or the fact that it doesn't follow the prompt. It will make sure that if you can actually give an input to GPT now saying that I want you to give an output that will feed into this particular function, and I can define the function. And there's 100% guarantee that GPT will make sure that it defines it in a way that the function can use it. So this is something still very new, but what it does, it now reduces this risk. And as we already said, LangChain already helped reduce the propagation of error. Now, both of these two things combined could lead to a whole different ballgame of a lot more.
Nikhil, sorry, some folks might not know what GPT functions are. So you might want to cover that for like 10 seconds.
Sure. Again, like it's very new. What really is happening is if I have a free text response, like email Anya about coffee next Friday, right? It will actually give an output. GPT will give an output that represents the input to a function. Like send email as a function. You can define this function in a different file, and you can actually input this function into GPT. It now has a new parameter. I'll show you what that parameter looks like on the next slide. And it will make sure that it gives you an output that fits that function body. The only way to do this earlier was using prompts. I'll show you what an older prompt looks like, and I'll show you what a new system definition looks like. So before we had GPT functions, if you were to kind of guide a GPT system or GPT-4 to make sure that it gives you a JSON response that can be fed into an input of another function, you had to give a huge prompt like the following. I'll take you through the prompt and you'll see how cumbersome this is. So use a JSON blob to invoke a single tool and its parameters. You would like to do it like this. I'm defining exactly how I want it to kind of give an output. I'm also telling you, I'm also defining more rules that you cannot invoke more than one tool at a time. And you must follow this response in every assistant response that you do. That there's a thought, define it like this, there's a thought, and this is the command. And you kind of keep defining it in a way that it must respond. It must respond with this type of output, because this is something I can feed into a function. I can go to this tool, which is the function name, and I can take these parameters to that function. However, you'll see that, first of all, writing these type of prompts is very cumbersome. There's a huge scope of error also. And in many cases, you see that this type of output doesn't happen. But with GPT functions, what you do now is that you have something new. When, as we just saw Jacob showing us on LangChain, that we define things like the model, we define things like the message. The user message is like, what is the weather like in Boston? What we can do now is define something called a function. Define something called a function. This function would have a name. This is the name of the function, is defined in a different file. It would have a description, and it has a description of the parameters that go into this function, and also what type, with some examples as well. So this will make sure when you actually run this, GPT will for sure give you an output that follows this function definition. So you reduce your error rate. I hope that makes sense. And what is really happening under the hood is, you've heard of things like GPT plugins, right? How do plugins always work? How does it know to call that API of that plugin? Well, under the hood, GPT was using GPT functions to make sure that those calls were happening correctly. They've just made that public for anyone, including you and me, to use. And that will help us make better API calls through GPT, enhancing its capability of doing tasks. So if there's any questions around GPT functions, I'm happy to answer. Otherwise, I can move forward to the next set of technologies.
I think one question from Shreyash, I think you might have already answered. I'm just repeating here. How are GPT functions reducing error rate? It is just a tool with which it can talk externally. LLM itself is the same.
See, this is a new input. Imagine when you talk to GPT, if you use the API, if you use the GPT API, now there's a new parameter I can put into that API, which is called functions. So GPT takes that input in, and it will make sure that when it gives an output, the output is something that will fit the function definition that I've put in with 100% accuracy. So it's almost like some hard coding is happening in the backend of GPT. They've written this code. Earlier, what used to happen is the only way you can control GPT is by prompting it, by writing these very complex prompts. But there is no logic that forces GPT to only follow that prompt. As you've seen, it hallucinates at times. It also doesn't follow instructions. That could happen maybe in 10 to 20% of cases. But with GPT functions now the fact that you have this extra parameter I can put into the function call when I'm invoking GPT, it reduces that error rate, essentially. I hope that answers the question.
Yeah, I guess. One more question, which is, can we submit multiple functions to the same prompt?
Actually, yes. You can submit a list of functions, and GPT will then figure out which function is the most relevant. And that's why you're actually putting these other things as well, like the description and the name. So the description is used for it to figure out which function needs to be called. It then looks at the parameters to figure out, okay, how do I set this function up so that I can call it? And then it'll give you a response. In fact, there's also another setting called auto. And auto kind of helps you define, like it gives you the freedom that you can use any one of the functions that I'm passing through. And as you can see, the functions is a list. In this case, I've only shown one function, but it could be a list of JSONs.
Cool. I think this is a smart question, which is, does GPT take into account functions when they count prompt tokens? And do they need these also, do they feed these functions into the model, right? So if we have some proprietary function, that information is going into the model itself. So
okay, I don't have an actual answer, but I can we can kind of brainstorm a little bit along the side. I think if you were to kind of build this within GPT, all you have to do is put some guardrails on the outcomes or on the output. So GPT would do its own thing. It would come up with an output. And I believe they have another layer on top of it, which uses the parameters of the model. And this is more like a rule-based engine that it must use for it to pick a function out and then make sure that the model is able to kind of give an answer that fits the function definition. I'm not sure if that counts extra in your tokens or not. I think it's more of a rule-based system, in my opinion. So for now, I don't think so. It shouldn't. Ideally, it shouldn't. For example, when you use a plugin, when you use any GPT plugins, it's not charged extra for that plugin use at this moment of time if it's a free plugin. And the same logic is used in GPT functions. So I don't think so. It should be extra.
I think somebody's mentioned on the attendees that function inputs are counted for used tokens. So they are probably. I think there's a bunch of questions on functions in themselves. I think maybe we can visit those after we finish the chat on, after we finish the presentation, come back to answer these questions. I think a lot of people might have more information and questions on this.
I think I would just recommend people to give this a shot. It's something so new. Like I said, it's less than 48 hours. I've been just using it myself a little bit over the last 24 hours myself. It's still something that we have to explore, but I would urge everyone to give this a shot because this seems like one of the biggest releases after GPT-4 was actually announced. So GPT-4, then plugins, and then I feel that GPT functions is at the same level in terms of an release. So go wild. I'll do a small homage to the things that were discussed by Jacob, and that is by a couple of frameworks that work really well. LangChain is a framework, and AutoGPT is kind of like a model that someone, it's also a framework, but it follows a different approach to LangChain. LangChain is supposed to be a very kind of build your own kind of system. As you saw with Jacob's code, you could kind of define each step, you define these checkpoints, and it comes with a lot of these built-in features that help with the pre-processing and post-processing. And we talked about this concept of agents. Now, agents are basically predefined chains. So imagine what LangChain will look like 6 months into the future. All basic use cases, for example, printing a document or sending an email or sending a WhatsApp message. I don't know what it would be. But these could become like, predefined chains, which are pretty accurate. And these chains will become agents. And then you can figure out which agent to actually use. You can combine multiple chains together to kind of come up with your task. So GPT kind of has a wrapper, which is these chains. And I can structure multiple chains together to kind of solve the task that we defined. So again, it's these chains are coming up left, right, and center. So I would say over the next couple of months, some chains will become more popular than other chains. So LangChain will become the base framework. Then you would have a couple of chains that people use, and then you could just keep building on top of it over a period of time. And with AutoGPT, this is less of a framework for you to actually leverage. This is more, it's a full-fledged kind of system that you can actually interact with. And the beauty of this, without going too much into depth, is that it is a GPT system that can invoke other GPT systems on its own. It has something called a task manager, which is basically the main GPT system that maintains the context and what needs to be done. So basically the logician. And there's another system that will take those details or the memory and actually create tasks. And then it'll create prompts. And those prompts will be sent to other GPT chains or other GPT systems. And they can do very complex and highly magical things, I would say. But you have to understand both of these systems have a lot of pros and cons right now. So I think the pros are, as we mentioned, we just saw right now in this session, that you were able to build a highly complex use case, which is information retrieval in about 30 minutes, which is insane because most of the heavy lifting was done. LangChain just came in the middle and it defined those checkpoints so well. So things like data retrieval, creative tasks, both AutoGPT and LangChain do a really good job. AutoGPT, for example, is great with creative things. If you give it like open-ended example, like help me devise a meal plan, it'll keep asking you questions. When the task manager, when it's trying to create things and it has confusions, it'll actually create intermediate prompts and ask you information. And so in terms of communication, it becomes a very different type of experience. When we think about automation generally, it's all the steps are automated from end to end. That whole logic is encoded. But with things like AutoGPT, some of those things are left to chance. It could change based on the prompts you give it. So it's the first attempt at actually creating this DFA that we defined in the GPT ecosystem, and that's what makes it great. And you'll more likely hear LangChain than GPT going forward, because GPT itself will not become an enterprise tool, it'll become a B2C play. But in the B2B world, if you're trying to sell something or create some use cases, it's going to be about LangChain. The cons are actually quite significant, have not actually gone to list them out. But one thing that we kind of give pride to GPT is its handling of memory states, that it knows what part of the conversation has taken place. But that is actually something that LangChain and AutoGPT both have a hard time maintaining. You have to explicitly keep telling the system that this is the conversation I've had. You have to keep storing that memory. So the objective of you handling that memory is in your hands. It's not something that the framework is actually taking care of you. And so when you use GPT natively, GPT takes care of that memory for you. When you shift to LangChain, GPT is only used for single tasks, and that memory is kind of shifted away from GPT into the framework LangChain. And LangChain doesn't do any effort to maintain that memory. You have to do it, at least right now, at least in this version of LangChain, which makes complex coding actually harder. And making complex DFAs is actually not as straightforward as you might want it to be, especially if you want to remember something which requires previous information, right? And in many cases, it still requires a lot of human intervention, and it prevents us from saying this is actually business ready right now. But however, both are significant leap in that goal-oriented task automation space. Still not there yet, but it's a very good improvement from where we were of just using GPT for everything. Right. So these are the two different these are the different advancements that people are using right now. There's a lot of other things happening on the side, but I would say, for example, the usage of open source models, etc. But in terms of the frameworks available for you right now in the market, it is basically leveraging GPT to the best ability and using things like LangChain to actually build out these finite state automata. So if there are no questions, I'll move forward on how we can actually overcome the limitations I talked about, which is the final part of my presentation.
I think there are a bunch of questions. It's become like a explanation of functions. So I think we can take them in the end. There was one question, I think two questions probably, which one is, what's the best tool for identifying, capturing, and addressing errors or hallucinations of production level GPT bot? How do you figure out there's a hallucination in the production?
Actually, there's two ways of doing this. And one is actually a manual way. And this is what we do at Limechat as well, that we have a system, we have built a monitoring system that takes every input, prompt, and summary and stores it in S3 so that we're able to kind of see. At the same time, we have to go in a manual way to tag whether or not that output was good or not. One more thing that you can do is actually try to train. It's similar way as you train an ML model, right? You create a test set, you create a train set. So I would create copies of my input and summaries of my conversations, and I would define the right type of response I want. And then we would run that type of training data over my current configuration, because what can you change in GPT? You can change things like temperature. You can change things like the prompt itself that you're using at different stages. And you keep using that training data set to making sure that at least in most of the cases you want it to perform, it's performing. So, and then we use manual intervention to keep, to kind of expand that training data set right now. I'm very open to hearing more better answers on how to do this. But right now it's a mixture of just doing a lot of manual labeling and building up a huge training data set. And in fact, that slowly starts becoming a moat when you're trying to solve a particular goal-oriented task.
I think Madhu has asked one more question, which is, are you using any specific platforms to manage training data? Are you using vector databases for the training data sets?
For training data sets, see, we use databases for retrieval, as we saw with Python, etc. We would use vector databases. So, for example, again, coming back to what we do at Limechat, we help automate queries for e-commerce brands. So they would have a lot of data on their website. And what we do is when we create these bots, we do a pre-processing. We pull out all this data and we pre-create a lot of FAQs out of this data set. And that goes to a rule-based system. And if someone asks something of those FAQs, we're able to handle it. If something comes out of syllabus, basically, then we kind of trigger the system to go and retrieve from your backend database, which is the entire website. So we do retrieval over there. So that is stored as a vector database, but our other training data, etc., is actually not stored in the form of vectors. It's literally, I match the output. And this is something that you can actually use GPT for as well. You don't have to give that output to a human to check whether or not the outputs are matching or not, because this is real text. It's natural language, right? So it might be that GPT gives an output and it doesn't match word by word to the output you have in your training set or your test set, sorry. So you can't do any kind of algorithm to do a match. So you can actually use GPT to do that matching for you, whether or not GPT feels like it's a match or not. And that helps automate a lot of the processes. But everything is really stored in free text.
Got it. And again, this is slightly rhetorical question. This connecting to your DFA framework, won't an advanced LLM allow? Does an advanced LLM not allow a level of abstraction on the DFA?
See, if you actually understand what a DFA is doing, it is like the functions that you're writing in a piece of code, right? An advanced LLM, you have to understand what LLMs are good at. Yes, I agree. LLMs are good at reasoning. So if I have any creative type of task or data retrieval type of task, it would be good at doing that. But let's say that my LLM has to make 3 different API calls to come up with one answer. Let's say it has to do an SQL query call, and it goes in your database, it does an SQL query, pulls out the data, understands that data, and it has to do, I don't know, 3-4 more steps after that. So just saying that put more parameters into this model right now, again, with the models that we're working with right now, getting great accuracies, as we mentioned before, doesn't work out, because at each step, there is error being induced. So that's why these frameworks actually came up. LangChain, etc., became frameworks which put checkpoints in the middle of this whole long kind of system. Like, if, for example, if I go back to this system itself, how do I code in this logic at this step? If you see this logic, the logic, I'll explain what the logic is, and you think about it. How will LLMs actually represent that? So if I know the concern of the customer, let's say that there's 2 different types of concerns here. Someone is facing problems with kidney stones, and someone is facing problems with low BP, let's assume. And if it is kidney stones, we simply just show multiple products, as we have 3 products for kidney stones. But if it is low BP, then we go into a different flow, which is diagnosing the concern and sharing the only one product that they should use for low BP. Now, if you want to code this logic into GPT and make it follow those rules precisely, you can prompt it, but you cannot ensure the correctness. And when this thing goes to production, you have no idea whether it's going to give a right result every single time. And the one moment it fails, the customer is going to come after you and saying that it recommended the wrong thing to my customer. Please shut everything down. So we have to assume that it works 80% of the time, great, but it has to work 100% of the time. And that actually leads me to the next portion. I'll talk about how we kind of solve this as well. So we kind of covered a lot of things about where things fail. So the first part is like, obstacles in actually progressing with that DFA. Like, you get unexpected user responses, unhandled exceptions, and that stalls your progress towards the goal. Meanwhile, what also happens with GPT is, if GPT helps navigate, like you're on a happy path and someone asks a random question and GPT has helped answer that question, it's very difficult for GPT to bring back to the happy path unless it just goes in a different tangential altogether. Apart from that, we also talked about executing like API calls, etc. This portion, by the way, might be solved with GPT functions to a certain extent, but still, as of now, it's a big problem to make sure that GPT fits in that thing. And the second 2 parts are very important, making sure that you don't have hallucinations, no misinformation, no misrepresentation, as well as the tone in which you're actually talking to the end customer. These are also very important, the guardrails. I'll tell you some examples that have happened with us. There have been places where a customer is asking about a product, and we are giving them, they're asking an FAQ about the product. Is it safe to use, or does it have this type of side effect? And you must understand, that's a very serious question. And GPT actually gave an answer, but it picked up that information from a different product. So there were 10 products, let's say, and someone is asking about product number 1. It actually picked out an answer from product number 2 and gave it. And it was wrong. It was the opposite of what should have happened. And it's very hard to control those type of cases. So you need to put the type of guardrails to make sure that the response accuracy and the information that you're giving is important. And that's why I've kind of I put this thing on the side, that enterprises prioritize accuracy and reproducibility over novelty, very honestly. You can be as novel and say that everything is happening through GPT, doesn't matter. While these innovative features may impress, but handling failure cases is a true measure of AI automation success. And this reliability is what builds the trust and will drive its adoption in the corporate world. So always think about what edge cases are happening and how do you mitigate those edge cases right now. So this is what we came up with, basically. So what we did is we understood the trade-offs of where GPT works really well and where maybe rule-based systems work better. Right. So we came up with 3 different criteria to think about it. The first one is exploration. And this kind of points to things around creativity and flexibility in our system. We talked about temperature. So GPT has that ability to kind of do a wide stretch or a wide search, kind of like a breadth first search kind of system, exploration. And whereas a rule-based system is more better for exploitation. Once you know what to do, you actually want a rule-based system to handle that case instead of making sure that something that a rule-based system could do, you're trying to do it with GPT, doesn't make a lot of sense, because this is more precise, it's more correct, and it's more ideal for these complex use cases. And third, and maybe even one of the most important things from both sides, from a business side, is the cost management. If you're going to do everything using GPT, that is going to leave a cost, especially when you're doing it at scale. For example, if I'm handling 1 million conversations a day, and each conversation is like, I don't know, a cent, you can just do the math. That is still expensive. And this cost is being borne by the end customer. So if you can build a more, and this will reflect in your pricing as well, right? If you're using a system that only uses GPT everywhere, you might have to price your product a little bit higher as compared to someone who's a little bit smarter. And what they've done is they've used GPT only in the right places, maybe only in 20% of the cases. So their GPT cost is actually 1/5 of your GPT cost. And your gross margins are worse than theirs. So what you can do is kind of use cheaper intent-based or rule-based systems wherever that path is well-defined in that DFA, and use GPT in the harder places where it requires more creativity, more search, etc. And it's very easy to talk about it, but when you're building, you will start understanding the trade-offs and which part of the design do I use GPT, which part of the design do I actually use rule-based systems. And that actually helps you come up with a decent architecture or AI architecture. So what I try to do is kind of summarize it so that becomes easy to understand. So I don't know how many people are familiar with things like RASA, but it's a framework you can actually build a lot of intent-based bots. So the way that RASA works is a classification model. I can define, let's say, 100 intents in my system. And based on the free text, it tries to map the free text to one of the intents coded into the system. And each intent leads to a very definite action. And that action is basically a rule-based engine after a period of time. So the ML part or the AI part is just to help do the classification on the list of intents. So it has a couple of strengths and weaknesses. For example, it's always correct because once it reaches the action, it'll do exactly what you tell it to do. It will follow those rules. And if you've coded the actions to reach a goal, it will follow that. Whereas in the intentless systems of GPT, you cannot guarantee this. You can't. However, what it does do, it helps you with things like harder queries, more creative queries, and it's much easier to set up. So what you can actually do is build a hybrid model that merges the best of both based on the trade-offs I talked about in the previous slide. And that's kind of reflected in the model on the side. Let me just kind of go a little bit deeper into this model so that you can kind of see what's happening. And this is what we're actually using live in action at Limechat. And this has worked out the best for us as compared to any other architecture we've tried out in the last 6 months. So to take you through it, it starts off with this user at the top right. And we have a bot interface. This could be like any messaging platform that allows us to pick up the messages. The message will go into our intent-based classification system. Now, like I said, it'll try to classify it to one of the existing intents. if the intent is matched, it follows the green path, which is my happy path. And there's an action server, which has predefined logic. The DFA is literally in this action server. The action server is the DFA, which I talked about, essentially. So it'll follow it step by step. And why is this level 3 conversational AI? Is because the system in Rasa and the intent system that you have, number one, it allows you to handle free text. And the intent matching actually takes into account the summary of the conversation or the memory of the conversation, or what we call the context of the conversation, to come up with the right intent. Now, in most cases, this should actually work. And to give you exact numbers, the automation rates that we typically see in our industry is around 80 to 85%. There's only a 15% confusion rate that we see, 13 to 15% actually. Now, in the case it's confused, it's not able to match into an intent, I will actually try to leverage GPT to figure out the intent on behalf of Rasa. So what GPT is now going to do, it has access to the intents defined into the system, and it will try to use logical reasoning to match that intent to one of the, so try to match that free text to one of the intents in our system. I'll give you an example of this. Let's say that someone comes into the system and says, I have low blood pressure, right? I really don't have any intent created for this. The system would be like, I would have intents like find product, and then it would have a concern. And low blood pressure is a concern, but just when someone says, I have low blood pressure, there's no intent. The person is not really explicitly asked. They're looking for a solution to it, or they're looking for a product for it. That's when GPT can actually come. So this step, GPT can actually do that inference, because that is one of the tasks GPT is trained on. So when you type in, and you can give it like the prompt, like you are a doctor, and you have to help people with their queries, help them find the right type of product. And when someone says, I have low BP, it can actually understand that, do the inference, and it'll call that find product intent, which your normal intent management system could not have done. And what that does, it sends it back into the happy path, and you're good to go again. Everything is on that happy path. GPT just helped you come back on track. Now, this will take care of another 7 to 8% of queries, actually. So what are you left with? You're left with around 7 to 8% of confusion still, where GPT doesn't even know what's going on, which intent should work. So what it does is that now you can kind of put GPT in a creative mode. So over here, the temperature is 0. I think you understand what temperature means by now. That means it doesn't have creativity. It has to follow the rules. But then you crank up the creativity, and you crank up the creativity to something higher, and you give access to the vector databases that you have, which we talked about earlier. And you allow GPT to take that question and do a search over the entire vector database and kind of come up with an answer. So this is where that happens. It'll kind of do an answer generation, and it'll take that response and give it to the end user. And even if this fails, now you might say, how can this ever fail? GPT never tells us that it doesn't know. It always says that we know. So this is, I would say, the most important part of this entire system of defining when to say no. That means, when do you tell GPT not to actually give its answer to the end customer, because it could be potentially dangerous, or you don't have a lot of confidence on it. And that is what this will start to become a moat of certain companies over others, because this architecture can actually be built, but the rules you build and the data that you collect and the training instances you figure out, the guardrails you put in figuring out which outputs do you actually want to show the customer, and where do you say that, no, I actually am super confused, I'll give it to a real human to take care of. That is the magic sauce here. So this kind of defines what I would call a hybrid architecture that can take up your automation to a very high rate, and you're really limiting the type of hallucinations that are happening in the system, as well as the misinformation that could spread. And this works for very complex use cases. Like I said, we're using this for complex DFAs. The ones I showed you in slide number 2, it's maybe 3 to 4 times bigger than those. And it's able to handle those with ease at this moment of time. So yeah, I think that's a little bit about, I wanted to kind of take you through that. Here's some resources I collected. I'll be sharing the slides with you. You should just take this with a pinch of salt, that things are changing so rapidly. You must figure out a way to stay up to date. Like every single day, I'm reading some sort of newsletter or some blogs. ChatGPT functions, like I said, have come out very recently. Do read about that. Try to stay up to date, because whatever new innovations happening, it might make a lot of the previous work redundant. And that's a scary thing also, because if you're putting a lot of effort into something and building whole infrastructure around it, you have to be flexible right now, I would say. The next 6 months are going to be very, very fast development cycles. As Jacob was also saying, we still figuring out the basics of PinePhone and everything else, what works, what doesn't work. But yeah, that's it from my side. Happy to take more questions.
Yeah, thanks for that, Nikhil. Maybe if you could unshare, and then what we will do is we'll start answering some questions, start taking some questions and answering those. I'm just following from the Q&A tab. There are a bunch of questions. I think the obvious one, which I would also love to know, is, are there any resources from where we can learn about building these hybrid systems? Short of you obviously writing a book.
I think it's actually very new right now. There's not a lot of resources. So the fact that we were able to come up with this kind of goes into the knowledge of our understanding of LLMs. I see a lot more systems coming up these days, but to be very frank, I think a lot of those systems are very superficial in nature. People are just using LangChain without understanding the implications. And I think this is what sparked one of the reasons of having a webinar like this as well, where a lot of people say, oh, LangChain is here. And Jacob showed a very amazing example of how LangChain can be used. But there are so many cases where it will fail, but people don't know that. People will only look at, oh, it did an outcome. And so it'll take some time. You play around with it. Just keep that in the back of your head that not everything has to be solved through GPT. In fact, try to solve it without GPT and then use GPT only where necessary. And with that mindset, you might actually have better success. I've seen a lot of people, I've also helped and advised, where they do the opposite and it backfires because you waste a lot of time in that. And it's also expensive. So I'm happy to share, if there's more detailed questions about hybrid architectures, I'm actually happy to kind of connect even offline. And this is something that I'm really passionate about as well. And I think there's going to be a lot more research being done in it. And you have to try it out. I think the more you try it out, the more experiments you do with it. So I would be in a much better state to answer more about it maybe after a month or 2 months, because it's still evolving.
And this question probably goes to both of you. Shreyash has asked this question, which is when to say no from GPT. So you like Nikhil, you said we can train an in-house ML model that has learned from previous responses. Is that the moat? Is that the differentiation it will create? And Jacob, you guys also think about that, when to use GPT, when to not use GPT, and when do you use some other model?
Jacob, you want to take that first?
Yeah, sure. So, okay, now, first of all, you have to think that generative AI is a part of the entire, AI stack that you are having. It is not a solution for every problem, but there are few problems which it can solve very nicely. So some of the cases where, Nikhil had mentioned about the hallucinations part. And if you're building on a private GPT, and in our case, we got that, from the context or for the documentations, and there is no specific answer, right? That would you like to reframe? So if you ask GPT-3 as a standalone thing, you will get hallucinations. But when you're doing, on a private doc, a retrieval augmentation, you get these sort of nice responses. So for simple use cases, right, the one that I showed you, this kind of works nicely. But then when you're looking for more intense stuff, right, now you might, like what Nikhil showed, right, you will need to have an intent classification stuff. Now that model itself, either it can be rule-based or it can be model-based. Probably you can have a custom model on a text Da Vinci kind of a thing. So, but those kind of things you need to understand where to put, how to plug in different sort of models together and come up with a solution. Don't be fixated on just generative AI. See what works in your use case, right? And then arrive at an answer. For example, for us, if I have to suggest, if a user is coming in and if I have to create a platform for our users, right? Not for just our platform, for our B2C users, right? So there, if I have to create a recommendation system, a chatbot for and combine it with a recommendation system, combine it with a segmentation engine, there I can't just rely on generative AI. The recommendation engine will come from my other AI stack, right? My segmentation engine will have another AI stack. So I'll have to marry these things together. And what GPT does beautifully is have a nice conversation around it. So, to each its own, just disclaimer is don't be fixated on just one aspect. It's like, your Python can't solve everything, right? You need to have in your own stack, you have Java, you have JavaScript, you have so many other, stuff. So it's like, Python can solve everything. It's like that.
Absolutely. But at the same time, it can solve a lot of things. And a lot of things, like literally every single developer should definitely be using this on a day-to-day basis, without doubt.
This is one generic question from Ranjit, which is, can we ask the chatbot to set up a WhatsApp or SMS reminder for someone else for a task? Like, for example, people here can just say, people start sending me WhatsApp reminders at 9 o'clock, to all of them to Priyank, using Limechat bot. What are the challenges on privacy angle of Facebook, and the restrictions on EU region because of GDPR? I think this is more specific to you, Nikhil.
Well, this is a very different, I don't think this is a GPT related question. This is more about how do we build, if I got the question correctly, you're asking about the privacy concerns about pinging people, with basically privacy concerns around automation, right? Where
yes,
I can leverage like
it's
Instagram, WhatsApp. Absolutely, you have to be very careful about these things. See, each country has its own rules and regulations. So in a nutshell, if you're doing anything outside India, especially with WhatsApp or anything, you need to get a consent from the customer. Now, there's many different ways to get consent. You could put something on your checkout page, you could put something on your homepage, you could put a banner on your website when people are coming in and out. That's a different conversation altogether, but you need to have consent. And if you have the consent, you can send it out to them. These type of channels are doing trying to do a really good job of preventing spam, whereas it is using AI. So WhatsApp, for example, is using AI to mark the type of messages that people are trying to send. And it is classifying messages as something called marketing messages if they're promotional in nature, which is basically spam. And number one, it's charging approximately 2 times the price for those messages. And with each one of these messages, the customer will always get an extra option that the sender cannot control, which is called stop promotions. And so basically, it'll use AI to start to filter out spam related messages on these channels and make it really easy for the end receiver to actually opt out, which has been a challenge in other places, I would say. So yeah, I think just be careful about it, but there are ways coming. We're working very closely with WhatsApp right now to make sure that those things are safe and spam is actually not done. Again, happy to talk more offline about the challenges over there, but yeah.
I'll pick 1 or 2 more questions. And this is again, both of you, I'm just rephrasing Vaibhav's question, which is, do you think the human label crowdsourced data can be used to improve existing automation? I think this is more around fine tuning. Have any of you tried doing, human label crowdsourced data?
Yes, so maybe I can take this one. We do that a lot. So we have a whole concept called online learning, which has 2 different parts. So essentially what we do is that our systems are out in the open. And when you're actually using intent-based systems, hey, hi, Anag. When you're using intent-based systems, you actually have something called a confidence threshold that you can actually see how confident are you of that answer. And you can flag out all the places where your confidence is under a certain threshold, let's say 50%. It's a multimodal classification model, right? So you would have a peak on any one of the intents. So if you don't see a good peak, that means it's confused. And you can mark all of these and you can actually give it to the end customer to actually label. And so our customers actually have an interface where they can see the failed, like where the confusion is high, and they can actually add training data or they can actually make changes to it. So essentially what's happening is by putting this in the hand, making the UI easy, you can actually crowdsource training from there. you have to put in the checks and balances. And this is again where GPT actually helps us. GPT will help kind of do a first level check to make sure that the person is not doing something completely random that breaks your fundamental models. Second thing you must do here is make sure that your models are disjoint for each customer. That means the way that your architecture is set up is not like you have all your data in just one big data file or data structure. Break it down. In fact, to share with you, the way that we break it down is that we have one core database, we have some domain specific databases, and then we have one database for each company. So that if a company makes a change, it's only changing the things in its own database. And then our team actually goes and figures out what has been added. And we make the decision whether or not to add this to the domain specific database or not, whether or not that training information gets promoted across companies or not. So there's a good checks and balances here, but a lot of this part is fairly automated. And that helps you train a system much faster. And yeah.
Jacob, you guys have like a customer support team. Like, do you use any of that data to fine tune the models or train the models better? Like answering live questions from your own.
Yeah, so that's our next task basically to have. So we have various knowledge base, like internal knowledge base. We have the Jira tickets, we have the Slack interface, Slack conversations and stuff. So a lot of tribal knowledge also in and around. So in addition to the documents, so if any query comes in, we will have, we are solving it by agents, and what we'll be able to do is give the right response, relevant response, because there are a lot of, first of all, there are a lot of repeat questions. And that we can easily answer. But then can we do something more where the knowledge, where the exact answer is stored in some obscure knowledge base, right? That is what we are trying to solve with the agents side of things. And once we have certain, level of success on that, then we can go on and, have a full-fledged customer response kind of a bot itself.
Good. One more question, anyone of you can answer. How do you find out if the factual answer given by GPT is correct or hallucination? I don't know. So this is like, this is the confidence, this is the hallucination, right? So I think it's maybe you do the training and train and check, right?
So I think if you're starting it afresh, right, there's, no better solution than doing a manual check. How can you do that without having any data in hand, right? So once you have, like Nikhil said, once you have sufficient data, then you can create models out of that. Unless you have come to that, it's going to be, manual.
I'll add another layer to this hallucinations thing. We might say that we don't have control over hallucinations, but I believe that's also not correct, in the sense that if you start making a list of every single point the model is hallucinating, there's actually there might be a common pattern, and we've noticed these common patterns. And what you do is you train an alternate bot, because maybe you cannot put everything into one prompt, right? So think of a GPT system that has been trained; it can handle 80% of things well, but the other 20% it can hallucinate. You train another system which can do the other 80% well. So there's an overlap of 60%, but it fails another 20%. And you have both of these working in tandem. And so your hallucination rates can go down and you can use some logic, because you know the patterns, right, where it hallucinates. You can use some predefined logic to decide which GPT to use in certain cases as well. And so what is really happening? You're making more and more small specific GPTs, each one with a higher tolerance of hallucinations over a period of time. So as Jacob mentioned, you must spend the time. You have to saturate your head. It's like how benzene was discovered, right? It came in someone's head during their sleep. They just kept looking at it for a long period of time, and you figure out the patterns. And then as soon as you figure out a pattern, you can train another GPT around that pattern, and that reduces your risk.
And just to add to Nikhil's point, in our recent experiments that we have done with LangChain and this thing for the support bot, we have hardly come across a case for hallucinations. That we have run this bot across our users in our orgs, and we haven't had this scenario wherein there is a hallucination kind of a thing, hardly any hallucinations. But yes, like I showed in the demonstration also, there are cases where the responses, the quality of the responses could have been improved, wherein you have to, clear the context and, come up with the question again.
Thank you. And I think a lot of the questions around actually testing the quality of responses and like the adversarial architecture for is like we are now getting into agents territory, right? Essentially, right? So I think that is itself an entirely topic of its own. And then we at Axel, we were having this conversation between me and Anag where can actually agents be put into production? It's like the wild west. Like we are not talking about AGI kind of situations. There are a lot of questions. I don't know whether we have answer for everything. So is there maybe one question which any one of you would like to one question with Nikhil, you, and one question with Jacob, you would like to answer, and then we'll close out the webinar. I'm just reading through these, but
okay.
Maybe this one, which is what tools do you use to log all the chats of the chatbot to be later used for training data? This is a practical application. So,
Okay, well, this is our own internal architecture because we don't use any external tool to handle the data. I mean, again, we use basic things like SQL databases, no SQL databases, but the whole schema and the way that the information, the whole ETL pipeline, because this is our core data that we store. So what we do is the proprietary data that Limechat has, and is the fact that every single conversation that happens with us, it's called conversational profiling. I'm able to figure out kind of properties of that customer based on what they're saying, what they're talking, how deep did the conversation go, what type of questions did they ask. I can tell whether this is a hot lead or a cold lead or any other thing, whether if I send them a message, if it's Priyank, if I know that I sent him a message earlier and he has not opened that message, why would I waste another rupee to send him another message? Right. I'll maybe try again after 6 months. But if Anag has received that message and he's read it and he's even bought, I'll send again, maybe after 2 months or something. So that conversational data, you have to see how you want to exploit it. We have a whole bunch of ETL pipelines. Like I said, we use a database called ClickHouse. This is a columnar database, which helps put event streaming inside. When you're looking at conversational data, it's about the funnel because it's very hard to visualize because at every step of the DFA, you have branches that could go. It could be along a happy path. It could be a non-happy path also. And you have to kind of analyze all of those things. So the things like ClickHouse works really well for us. We're able to filter out things. If you want to use a tool, I would say Mixpanel is an amazing tool. Sure to get other people's feedback on it. It has great funnel diagrams. And I think that is one of the most useful things for any type of conversational analysis that we've seen so far.
All right. Jacob, any question you think? I'm just removing some of the function questions. We'll try to arrange a session, hopefully with OpenAI on functions. Looks like there's a lot of ones.
I think you need to wait for a week. There will be enough tutorials on YouTube on this, enough with code. Just be patient. It's just 6 months. So this thing has come up. Imagine what will happen in the next 6 months.
Yeah, I think that all of us are excited about that, right? Like all of this is already happening in 6 months. It's 12 to 18 months.
And what I've heard, I mean, I was just conversation on with the Google team as well. So they are planning to come up with full functioning app itself for chatbots. So,
oh, wow.
so probably, you might not even need to do anything. Just and then that's probably it's probably death knell for some of the chatbots who just created a platform to converse with documents.
All right. Okay. Thank you all. We'll close on time. Thank you, Nikhil. Thank you, Jacob, for taking our time. I know you guys spend Saturday and Sunday also discussing this stuff. So thank you for taking out your valuable time, and it's helping with all the folks. I think at peak we had like 130, 135 people attending the talk. I hope and thank you for all the attendees for staying there with us. So thanks a lot. Hope to see you guys more in our webinars in future and offline events as well. So thank you, everyone.
Absolutely. Thank you so much,
Bye.
Brent.
Thank you. Have a good evening, everyone. Bye.
Bye.